Welcome back. Now in this session, we will discuss about Inception of Azure Synapse Analytics. In the modern data warehouse, we receive all kinds of data ranging from structured, semi-structured, and unstructured. And that data will be ingested into the data lake. We'll then explore and prepare the data for experimentation. The data is then transformed and enriched with additional information, outcomes from machine learning models and data science experiments, and then stored in the data lake. The data is then modeled into relational tables. The required securities then applied and served for reporting. We then use BI reports to visualize the data. This is how a modern data warehouse architecture generally looks like. Let's now look at the solution projects we are implementing in Azure before the general availability of Azure Synapse Analytics. If you are new to Azure, you might not be familiar with some of the services discussed here, but don't worry. By the end of the lesson, you'll get a good introduction to Azure Synapse Analytics. I think it is important to understand the history and the limitations of the existing solution to gain an understanding about the inception of Azure Synapse Analytics and the features offered by Azure Synapse Analytics. Azure Data Factory is a superior tool when it comes to data integration. It provides connectors to 90+ sources ranging from on-premises, multi-cloud, and software as a service application. For the data lake, ADL's Gen 2 is undoubtedly the best choice with its hierarchical namespace, low cost, and better security. For Explore and Prepare, we could either use ADF Data Flows or Azure Databricks. ADF Data Flows gives us code-free development capability, but they lack the ability to process complex data structures and unstructured data. Databricks with its Spark notebooks is a great choice for those kind of data. Again, for transformations we can either use the Azure Data Factory Data Flows or Databricks. Databricks also comes with a lot of machine learning libraries to aid data science workloads as well. Azure SQL Data Warehouse is a massively parallel processing engine which can handle large volumes of data, suitable for handling large-scale analytic workload. Just so you are aware, for a period of time, Microsoft renamed Azure SQL Data Warehouse to Synapse Analytics. But Azure Synapse Analytics is much more than this. So please don't get confused. We'll go through the entire features offered by Azure Synapse Analytics in this lesson. Finally, we can use Power BI to visualize the data to gain insights. As you can see, there are a number of services used in this architecture. So let's group those services into 4 categories: data integration, compute, storage, and data visualization. As you can see, we have 6 different services in the solution, and each one of them require their own development studio, monitoring, and management. So as a developer, working on this will have to have multiple tabs open. And also we need to navigate to different workspaces to monitor these services. And most importantly, there's a lot of management in terms of being able to get these services to talk to each other and also set up security. All these compute resources are provisioned resources. They take a few minutes to become available and they are charged while they are running. There isn't a serverless query engine in this solution. The 3 compute engines are disparate and they don't share any metadata between them. So one service is not aware of the object created by another. For example, the Spark tables created by Databricks service are not accessible by the Azure SQL Data Warehouse to query. As you can see, there are a number of issues here. Microsoft's solution to this problem is Azure Synapse Analytics. It provides a single pane of glass for all the services and more. Let us go through each one of them. Within Synapse, you'll see Synapse pipelines instead of Azure Data Factory. But don't worry, you don't need to learn another tool if you're already familiar with Azure Data Factory. Synapse pipelines are exactly the same as Data Factory pipelines. Azure Data Factory and Synapse share the same code base for this. There are only a couple of minor limitations on this Synapse pipelines. Similarly, ADF mapping data flow in Synapse are called Synapse Data Flows, and it provides the same functionality as well. Instead of Databricks, you'll see a new service called Spark Pool within Synapse to perform big data analytics. This is a new service rather than renaming Databricks to Spark. In this case, Microsoft have taken the vanilla Apache Spark and Delta Lake and then built this service from ground up. So we won't have the optimized version of Spark and the Delta Lake that comes with Databricks instead. You get the vanilla Spark. Having said that, similar to Databricks, Synapse Spark Pool also provide this notebook experience with some small differences. You can provision Spark clusters of the size you need, and then you can terminate them when they're not required. Azure SQL Data Warehouse in Synapse is now called the Dedicated SQL Pool. This is just a renaming exercise. So if you've already worked with Azure SQL Data Warehouse, you'll feel at home. Dedicated SQL Pool is a provision resource that stores data in a relational table format with column in a storage. It also uses a massively parallel processing or MPP architecture to leverage up to 60 nodes to run your queries in parallel. On top of those three compute options, Synapse also provides a serverless SQL pool. This is a new service which is available on demand. We don't need to provision any resources. This lets us query data in the data lake using the Familiarity SQL syntax. Azure allocates the resources and runs the queries as required and returns the results. As we don't provision any resources, we are charged based on the amount of data processed rather than the resources provisioned. Another great addition to Synapse is the shared metadata across various compute engines. With the introduction of this, serverless SQL pool can now access the Spark tables created by the Spark pool thanks to the shared metastore. There is still some limitations, such as tables in the dedicated pool were not available to access via serverless pool, etc., but I hope they will be added in the future. A recent introduction to Synapse is the Synapse Link, which lets us replicate the transactional data in Cosmos DB and Azure Dataverse and then query the analytical store directly from Synapse without impacting the transactional systems. This enables near real-time operational reporting without the need to perform any ETL to bring the data from Cosmos DB or Dataverse into Synapse. We also have a level of integration with Power BI within Azure Synapse Analytics. We still need to create things like datasets in Power BI Desktop, but we can develop reports and publish them from the Synapse Studio itself. Finally, we now have one development studio or workspace for all our services rather than 6 different ones. So we can perform monitoring, development, management, everything from one single studio, which is great for a developer. This is broadly what Synapse is as of today, but Microsoft have been constantly working on bringing new capabilities into the toolset. For example, there is a new compute service called Data Explorer Tool, which is now in preview. This is specifically targeted at building near real-time analytics on log data and telemetry data. Similarly, Synapse Link for SQL Server 2022 is currently in preview. This will replicate transactional data from SQL Server into analytical stores and query the data in near real time without impacting the transactional systems. Also, there are many more features in preview in existing services such as Spark Pool, Serverless Pool, etc. So it's an interesting service to learn if you are futuristic. Finally, let us now look back at the definition. It's a limitless analytic service that brings together data integration, enterprise data warehousing, and big data analytics. As you can see from the architecture, it provides limitless compute via various compute services and limitless storage, with the help of ADL's Gen 2. Also, it brings together Synapse pipelines for integration, dedicated and serverless SQL pools for data warehousing and Spark pools and data flows for big data analytics. Basically, it provides a unified platform with the necessary tools required for data engineers, data scientists, and data analysts to perform their work. I hope this has given you a good understanding about what Azure Synapse Analytics is, and that's the end of this session. I'll see you in the next one.